This is the final project's EggTimer, and this is our diagram. And for our implementation, for this part, we we actually use some logics to do the multiplexing. So we can choose program mode or counter mode. So it depends on which mode we will have, and it will be the time and which is the minutes and seconds will be displayed on the LEDs. And another thing is here for the minutes, for this debouncing circuit, I use latch to do the debouncing. And for the this cook time, since we couldn't press both cook time and minutes or seconds together, because now we are just doing remote control, and we work remotely, so we cannot really touch the circuit physically. So I changed this cook time from BTNL to switch number 4, so that we can pause and then we can change the time. And here for the clocking, for the clock generation, they are similar to the previous labs. And for this circuit, for this timer on LEDs, I use a final state machine to make it. For this timer, which is LED 0, I just assign the LED using the switch number 0. So let's go to the code to take a look. So this is our code. So first I generate the clock. We have 1 Hz clock here, and then we also generate another 2 clocks for multiplexing to the LEDs, to the 77 LEDs. Then here is to set, we set the LED 0 using the enable switch. And enable switch is this switch number 0. And here is the reset latch. Here we don't have the reset function, but we actually need to implement it for the input of the IP catalog counter. So this is also a latch to make sure that the duration can cover a 1 clock cycle. And then here I implement this part, which is the timer on and the timer on LEDs using final state machine. So which is very simple. So this is the final state machine. I just want to make sure that when we press start, for example, when we press start, and we will see something here. That is the 1 Hz clock. And also we have to make sure that enable start first, and once we press start, it will start showing the clock. But after we disable it, this start button should go back to 0. So that's why we use a final state machine to implement it. Then after that, we implement the debouncing circuit for this part, for the increments of minutes and seconds, which is pretty simple. So we have 2 debouncing circuits. We have a lot of logics here. Why I do -1? Because I generate a counter which is up counter instead of down counter. So similar, I just copy and paste the bouncing circuit for the minute, and this is for the second. Then after that, we should talk about the counter. I generate a counter with load 8 bits output, and which counts 60 times. For a low, I actually have to use latch to make sure that it can cover the 1 clock cycle, which is to avoid the bouncing here. I have also load the output from the debouncing circuit. So these 2 actually is from the above. After some calculation, I like just add back to here to the low and load this new value to the counter. Then then this counter, the output of this counter will go through the logics. You see I have 2 clock here. These clocks actually is to do the triggering of this part, because now we have 4 outputs, so we have to use 2-bit clock to do the multiplexing. So now let's go to and then finally they are just some very normal stuff. We just go through the conversion from binary representation to the 77 LEDs. Remember that we have here generate a up counting counter, so I use extra logic, which is implement in behavior modeling to just convert the up counting to down counting. So yeah, that is the flow of everything. So let's go to quickly demonstrate what happened. So okay, let's restart. Actually, I have a reset here. This is the reset. Yeah, this is the reset, and I should disable. So here at the beginning, I enable the. So you can see LED is on and off, right? This is enable, and I start counting. Start counting is here, then it will start counting, and disable it, then it will pause here, and enable it. It won't count, but I have to start it again. Yeah, continue. Yeah, so basically I also can actually change the counter, increment the counter when I'm counting. You see it? Yeah. And then we have also this guy. Yeah, I can also change the minutes. And yeah, and also actually I have to pause it and do the up count. Sorry, increment. I have to pause it and increment it. Yeah, you can see it. And after that, I just undo this. Actually, this is the switch number 4. I set the clock time, so this is our program mode. When I press this button, which means this is in the program mode, then it will pause the clock, the counter, and then after I disable it, and then it will keep counting. And also during counting, actually I can also change. I can make it. I can change the increment the second or minutes when I count. So then I disable it. Everything will be will be frozen, and maybe I try to reset it. Everything will go back to to here to 000, and now restart, and we enable it, and yeah, we can just do the counting. So that's all for this EggTimer part 1. Thank you.